Hello and welcome once again to the Duke Williams online teaching platform. In this short video, I'll be demonstrating how to calculate option values, call option values, and put option values using the Black& Scholes option pricing model on the spreadsheet. So for advanced financial management students of the ACCA, this will come very handy. So what I do have on the screen, as you see, just a basic example there. You do have a share that is currently selling for 116 cents, 100 cents as the exercise price, time to maturity, volatility risk free. So essentially, you can understand that these are the determinants of option value. And in working out this, it is important that the candidate makes it clear to the marker what these option determinant values are. So let's just go straight to it. BSOP model. So the first thing I want you to, or you will need to do, is to find values for the determinants so that you can let the marker know how you arrive at your figures. So the determinants is the first stage, and the first one, the value of the assets. So we can have PA. So I have this. So that comes as PA. I have 115 cents. I have PE. You do have 100 cents there. Then time to maturity. That's 3 months. So a bit on that there. So time to maturity, 3 months. 3 months comes as a 3 out of 12. So yes, the market can see that. Then volatility. So our S, you need all this, the comes to 25. So 0.25, and then the risk-free rate of interest 0.1, that is 10%. That is the first step you take. Now, so that is what you do have here. You identify all these five determinants there beautifully, work it out. Make sure your T is in number of years so that it works with the formula. The next bit I would advise students to do is to find values for these four items because they will be needed, be it call options or put options. So my next stage is to find values for this. But then to do this, I can work these things out easily, but I would advise that in order not to miss what you are doing, just write it by the side that this is PA. You understand shortly why it might be necessary to write them out separately. So S multiplied by the square root of T. What I'm going to do next is just put equal sign in front of them and reference those values, and I'll have those values that I need. So I need E raised to that. Now, just a quick one. This ln is what you see here. The one I have here is what you see provided by the ACCA. Is the natural log ln. So we just put equal to ln. We have that. Then the exponential function exp, the number. And so when we come here, I'm simply going to do exp is going to be negative my r multiplied by the t, and I have that there. Then what I'll be doing, which is this bit needed here, is to open up a bracket for, so let's say my r add on into bracket 0.5 multiplied by s raised to the power 2, close it, and then multiply by t, and close it. So just so you know that what I'm going to do on this right as my first step. So let's say this is my step number one. This is going to be step number two. So in step number two, I'm looking for values here. So I go and type equal to ln, and I have my PA divided by PE. So this divided by PE, I reference that. So that becomes easier. Then I have this, I have S, okay, multiplied by the square root of T. So square root function SQRT into bracket. My T is giving me that. So that gives me this figure, nice there. Then I have equal to um, exponential. This time I'm doing negative of my R. So I have this multiplied by the T in years, and that should also give me this figure. So this is step number one, step number two, there beautifully there. Then my step number three is to find D1 and D2. So point number three, I'm going to find D1. I want to find D2, and then once I found that, I can come and work out ND1, ND2 as mine. So calculate D1, calculate D2, and then find ND1, ND2, and then what you do is plug it into the BSOP formula, and that's it. We are done. So what is D1? Now we know from the ACCA formula sheet, we can actually find this formula sheet from here on your platform. So come here and hit the formula sheet, and you can see that there. So that's the workspace, that's the formula sheet, and so Black and Scholes option pricing model for valuing European call options. So it says my D1 is this bit that I have calculated. So I have this, I have all these three components. All I need to do is to add them and divide by the S root T, and I'll have my D1, and then I can find my D2 as well. So let's just go and deal with that. So my D1 is simply going to be, it is this figure, add on, oh, I didn't do this. I think I'm missing that bit there. Sorry about that. Let me just work out this figure. I missed that. So this equal to, I have an R. So let me put an equal sign in front. My apologies. So an R, then I add on this into zero point 0.5, multiply that zero point 0.5 into the square of S. So raised to the power um, 2, and then close it and do that, and then multiply this by the T, close it again, and that should give me this figure. Very interesting there. So I have that because I need that for my this as I see it. So I need that. I need this that I've just worked out divided by that to come out with my D1. So let's go and hit that on. So D1 will simply be equal to, I have natural log of this, that add on this value I've worked out here, and then divide the whole lot by S root T, which is this figure, and that should give me this. So I have 1.3 801 or whatever figure you want on that. And then by my D2, according to the formula, is the value I have for D1 less S root T. And I do have those figures there, so nothing to worry about. So D2 will simply be this D1 take away S root T. So yes, that gives me that figure. Very interesting stuff there. And then my next bit, call it point number 4, will be to find ND1, okay, ND1, and then ND2 there. Now, how do we find this? Again, if you come here, this is where you have this function called dist, norm dist. Okay, so norm dist, not normal distribution. So you literally um, just demonstrate that. So it's going to be equal to norm dist. So normal standard distribution, norms dist. I'm not sure if there's an error in the publication where I don't see the S coming out. I'll just confirm. So you have this norm dist. So let's do that. So norm dist of the figure, so equal to, I have norm dist. Then I have um, 1, which is D1, and that gives me this figure. Then same norm S dist, I have that, and I have this bit. Now, I'm just being curious. I see that the SCCA bit doesn't got the S in there. I want to try if that would also work without the S in the middle. So norm, there should be an S before the this. That's what I was expecting. But let me just try that. If I have norm this, okay, equal to, so equal to norm this, um, that figure and that. Yeah. Yeah, so I think it might be a typo or something, but it should be norm this. So take note of that when you are using that. It should be normal, then S there to show standard, then distribution, just that. So I think what a typo error was missing the S bit there. So take very good note of it, and I think it's just a typo error there. So let's go back to what we have here. So ND1, and then we have ND2. Now, then from here, all we need to do is to plug them into the BSOP formula. And in the formula, it says the value of a call option is equal to um, the price of the line asset, ND1, then take away the exercise price, ND2, multiply by the exponent of this. Very, very, very interesting. That is what the value of a call using the BSOP model. So what I see on the left here, all I need to do is to work out what the value is. I can again decide to restrict the number of decimal places and keep life simple. So let's say value of a call. Now, what is that value? Looking at what I see on the left here, it is equal to a PA multiplied by ND1, and I have my ND1 here. Then subtract, I would need to open up a bracket because there are three things there. PE multiplied by ND2, I can find you here, multiplied by E exponent RT, which I do have here, and that should give me that value. Now, if I want to restrict this to certain number of decimal places, let's say 2 decimal places. Yes, I can have that to be this. So it means that the value of a call option on this is 18.0 cents. So as the question saying, it says find the premium to be paid on the cost of 10,000 call options. So that cost will simply be 10,000 there, because each option value will have this multiplied by, oops, okay, so my apologies, equal to this multiplied by that, and that gives us this. But don't forget, these are all in cents. So in terms of dollars, is going to be divide this by 100, I suppose. So it's like 1,800 dollars to pay for a call option on 1,000 shares. So that is it. So value on 1,000 shares if you want. Okay. Now, the other bit is we may be asked to find the value of a put option. Then we come and use the formulas provided. Now, the corresponding put option, we need to use the formula here. But this C you find here, that C is actually the value of this call option that we have already calculated here. So, value of a put option corresponding value, looking at the formula here, it says as you take the value of the call option, subtract the price of the underlying asset, multiply or find the present value of the exercise price. So I'm just going to do that. This is simply going to be the value of the call option I have. I'm subtracting PA, I have that there, and I'm adding, there are two things, so I'm in a bracket, PE multiplied by exponent that, and that should give me the corresponding value of the put option. So essentially, that is all that I'm looking at demonstrating here, but the BSOP model using the spreadsheet functionalities can give you answers quickly. But the important thing, as I said, is these bits here, let me just color them in red. The reason why I still demonstrated that so that you can know, because if you didn't show them, you only have to hit on them to know which one, and you have to run through all this. But then if you show them, fair enough, you know which one lines you are picking through. So assuming when I got to this figure and I needed exponent base and all that, at each point I will need to come and test which of these values represents what, and that can be time consuming. So if you find space to type them on the left without the equal signs before you use them on the right, they do come out beautifully. And so that is it. Obviously, this put value is only time value only. So that brings us to the end of using this. Once you know the 5 determinants, basically this video is to show you how you can find the value of a call option, the put option, simply using the CBE platform.